Okay, factoring special cases. This one's going to follow your textbook on page 528. So if you want to look there, it's going to be helpful to know perfect squares, like the locker problem, or the Easter eggs. Perfect squares. Here we go. Look at the activity on page 528. It's in a blue box. And it says factor each trinomial. There's something special about these trinomials. We have x squared plus 6x plus 9. We have x squared plus 12x plus 36. Actually, I think it's m and not x, but it doesn't matter. And we have x squared plus 10x plus 25. We could also have one, like a squared plus 18a plus 81. Okay. What do you notice about these last numbers? Hopefully you notice they were perfect squares. In other words, 9 you have 3 squared. 36 you have 6 squared. 81 you have 9 squared. 25 you have 5 squared. Maybe you're seeing the connection. 3 squared is 9, and 3 plus 3 is 6. 6 squared is 36, and 6 plus 6 is 12. 9 squared is 81, and 9 plus 9 is 18. 5 squared is 25, and 5 plus 5 is 10. Factoring special cases. We're going to have perfect square polynomials. Okay, perfect square polynomials. That's what these are. And we're going to talk about finding trinomials and what if it's the difference of two squares, okay? So let's look at factoring a perfect square when a equals 1. All right, this is example 1. So we have an example like this. X squared minus 8x plus 16. Okay? Special cases. So 16 is a perfect square. So I can have 2 times 8, and I can have 1 times 16, and I can have 4 times 4. Well, here's the only way I'm going to get 8. Notice it's minus 8 and plus 16. That means both of these need to be negative. So that means I have x minus 4 times x minus 4. Okay? But isn't this the same thing? Yes. So I can write it, the quantity x minus 4 squared. Okay? Let's do a couple of others. Let's try n squared plus 16n plus 64. And then let's also try b squared plus 14b. Let's do minus 14b plus 49. Okay, let's try both of those. Ask yourself, is 64 a perfect square? Check. Is 49 a perfect square? Check. Okay? So if it's a perfect square, what's its square root? 8. Is 8 plus 8 16? Check. What's its square root? 7. Is 7 plus 7 negative 14? No, but negative 7 and negative 7 are. Check. So then we get ready to do our bubbles. N plus 8 times n plus 8, which is really just n plus 8 squared. Over here, b minus 7 times b minus 7, which is just b minus 7 squared. Okay? What happens when a is not equal to 1? In other words, what happens when I have a coefficient in front? I don't know. Let's try. This covers example 2. So I have 9g squared plus 12g plus 4. Okay, is 9 a perfect square? Yes. 3 times 3. Is 4 a perfect square? Yes. 2 times 2. So when I get ready to match, I'm going to take 3 times 3. What is that? 6. Is 6, and I'm going to get the same, plus 6, 12. Yes. So my 9g squared comes down to 3g. Now we could have done the universal method and all of that, but this might just be a quicker since we know they're perfect squares. Plus 2 times 3g plus 2. So I get 3g plus 2 squared. Okay, let's try one more of that. 4t squared plus 36t plus 81. Okay? 4 perfect square, 2 times 2. 8 a perfect square, 9 times 9. What's 9 times 2? 18. Is 18 plus 18 36? Check. So I've got 2t plus 9 squared. Okay. Difference of two squares. This time we're going to be subtracting. This you'll find on page 530. The difference of two squares. This time we're going to be missing that middle term. And we're missing this middle term because one was plus and one was minus. So we're going to have two bubbles. And we know we're going to have an x here and an x here. But remember, in order to get a negative number in the last part, we have to have a plus and a minus. What is the square root? What is the square root of 64? 8. So that means I'm going to have a plus 8 and a minus 8. A couple more like this. What if I have m squared minus 100? What if I have c squared minus 36? Okay. I'm going to have a plus and a minus because I have a negative right here. So I'm going to have an m square root of 100, 10 here, 10 here. Okay. What about c squared minus 36? I'm going to have a plus and a minus, and I know I'm going to have a c. Square root of 36, 6. Because you see when we FOIL, we get a plus 6c and a minus 6c, and those will cancel each other out. Hopefully, this is bringing back some good review. Lastly, we're going to factor out the GCF. Okay? So let's look at this. What if we had 10x squared minus 40? Okay? Is there a common factor here in the coefficients, 10 and 40? Absolutely. So it's 10 times the quantity x squared minus 4. All right, now are we left with a perfect square? Most definitely. 4 is. We have to keep 10. It just didn't go away. And then we do our double bubbles. X plus, x minus. What's the square root of 4? 2. So here's our final answer. Okay, let's do another one. 3c squared minus 75. Will 3 go into 75? Yes. So 3 times c squared minus 25. Okay? So I keep my 3. Is 25 a perfect square? Absolutely. I have a plus and a minus. C plus 5, C minus 5. And that's my final answer. Be sure you see me if you have additional questions.